Today we're going to be talking about what's the scam. And other than just being a cutesy title, which is not what's intended here, this stands for Selection, Care, and Maintenance of Vertical Rescue Equipment. Well, why did we choose to call this scam? Well, it's not something of our design or our making. It's because soon to be released NFPA documentation, at least as it is currently planned, will be called scam documents concerning this topic of selection, care, and maintenance. So we thought we'd start using the term now and begin to get folks familiar with it. So, excuse me. There we go. Had a hard time getting started here. So today's presentation is really intended to provide some top-level guidance of some things that you should consider when you're going through the process of selecting your equipment. We want to ask the right questions, consider the important factors in your particular environment for the equipment that you're choosing, and then talk about some key specifications that will be important to you. Now, this presentation will focus more heavily on selection, even though there will be some care and maintenance. The selection portion is really more involved and also more safety related than the care and maintenance, which is pretty well covered by manufacturers of the equipment. So some things that you need to think about when selecting rescue and safety gear is that one size doesn't fit all. So what requirements you have will be based on how you're using the gear, what standards that you have to implement, those to which you must conform. For example, many fire departments, most fire departments will require NFPA gear. So we want you to think about your application, whether your gear is going to be for one single purpose or have to be multifunctional across various scenarios and environments, whether you're using it in a professional sense or a recreational sense, and then of course the performance requirements that you need to accomplish the task that you have and what requirements that you need to comply with. Now there are two different types of criteria when we in general categories, and those are objective criteria. These are the quantitative type criteria. You're going to have numbers and measurements, test specifications, standards that you have to meet. That will be the focus of this presentation, although there are also subjective criteria that will come from your impressions or personal preferences or usability. Your field experience may play into this. But today we will mostly focus on the objective criteria. Well, in starting this discussion of selection of gear, we wanted to bring up the topic of design factor of components. Now, a definition of that is the component strength divided by its anticipated load. What we wanted to stress here, though, is that it's more of an information item for us. The manufacturer's concern is the design factor more than the user's concern. So don't equate a design factor of a component to a safety factor in a system. And speaking of safety factors, the safety factor is what we want to be sure that we're considering when we select our gear. It is the weak point in a system that we're using, divided by the anticipated load in that system. And we like to think of safety factor as based on the weakest link in the system. You'll use the individual component minimum breaking strengths to calculate this in many cases, most cases, but you also need to derate that component strength if you're using it in a way that compromises the component strength, such as, we'll look at this in a little more detail in a minute, but such as three-way loading on a carabiner. If you have to load a carabiner in your system that way to use it, be sure that you consider that derating when you're calculating your system safety factor. And it's really important to understand this in your initial selection of gear, because you may need to buy different gear that would allow you to use your components in a way that would not compromise that component strength. So we're going to consider some of the most common components in rope rescue systems particularly, and start with ropes. The standards that you need to be concerned with when you're selecting your ropes are NFPA 1983 and Cordage Institute 1801. And we wanted to bring up especially that Euronorm standards do not apply in the USA. So since your rope is the foundation of your rope rescue system, you need to be sure that it meets appropriate standards. And in the rescue environment and life safety environment, well, particularly rescue environment, we'll be using static kern mantle rope or low stretch. Well, the reason is that the elongation that you would find in a more dynamic rope, a stretchy rope, would make loads difficult to control. They would have a bounce in there. You would have inches lost when you're doing resets of hauls, when you're using mechanical advantage systems. So the low elongation is for control and also to allow you to test strength in a way that makes sense. Now, if you'll notice the core yarns in the static rope, you see not much twist in there. We'll compare those to a dynamic rope in the next slide, but there's not much twist in the core yarns. That means that the twist doesn't act like a spring and stretch out as much, so we would have very little stretch in a static kern mantle rope, which would allow us to position and use them for mechanical advantage systems in a way that is not compromised by the stretch. And also another thing about rescue rope, static rope, is it will have a thicker sheath than the dynamic climbing ropes for longer wear. So dynamic, we want to point out, is a poor choice for most of your rescue needs. There's just too much stretch in it. Now, there are certain rescue situations where you would want a dynamic rope, such as a person who needs to lead climb to set anchors or something of that nature. And the belay for that lead climber, you would want to have a dynamic rope because of the potential of falling on that rope and the force absorption that you would gain from the stretch in a dynamic rope. Now, another thing, as we mentioned before, about dynamic ropes is they have a comparatively thin sheath when you compare them to a static rope, and therefore they are less abrasion resistant and more prone to being cut by sharp edges. Now, this is some test data on this slide that compares dynamic versus static rope. And because the strength of a rope is rated at 10% of its minimum breaking strength, now that's a 3 sigma value, so you're talking virtually all rope, 99% plus rope is going to be stronger than that value. So that's a 3 sigma value for testing the rope, that 10% minimum breaking strength. Therefore, since this 11 millimeter rope is approximately 6,500 pounds in strength for its minimum breaking strength, a 650 pound test load is put on this rope, and you can see the difference in stretch. If you go to the top left and look at the PMI 11 millimeter polyester core static rope, there's like 1% or less stretch, less than 1% stretch. You get into a kind of a semi-static category between 6 and 10% stretch, but you can look down at the dynamic climbing rope on the lower right of that graph, and you can see that it is stretching well beyond 10%. And this is what would make it very difficult to test for a breaking strength, and it doesn't tend to be rated that way. And what are our typical rescue diameters? What would you want to order if you're ordering a rescue rope? Well, typically they would be 11 millimeter ropes or 12.5 millimeter ropes. The 11 millimeter static ropes are about 6,000 pounds of minimum breaking strength. The 12.5 millimeter rope, which is half-inch rope, is used by probably 95% of the fire service for their rescue rope. Now, it is over 9,000 pounds, And in fact, the classic static is 9,400 pounds minimum braking strength. Some additional considerations when you're choosing your rope, and these get a little more into the qualitative rather than the quantitative realm, is the hand of the rope, and that's how soft it is and supple it is. The softer and more supple ropes, they're easier to rig, they're easier to tie knots in, and to reeve through pulleys. However, a stiffer rope tends to be more durable and more abrasion and snag resistant. And one thing, if you're going to have to ascend rope, is to realize that the stiffer rope is also easier to climb with an ascender. So these are kind of the qualitative things that you need to think about when you're getting your rescue rope. And care of a rope, we've gone into detail in other webinars, but basically the thing to remember here is that you keep your rope clean, it's going to last longer, and that's in general for soft goods. So inspect it regularly, wash it in cool water with a non-detergent soap. And I'll refer you back to an earlier webinar for more details on rope selection, care, and maintenance. Harnesses. Well, what are the applicable standards for harnesses? Again, NFPA 1983 would be important for fire service, ANSI Z359.1, and the UIAA. Now, the UIAA is generally for climbing harnesses more than industrial work and rescue harnesses. So you need to consider when selecting a harness, again, what your regulatory requirements might be. What are the tie-in points that you're going to use for your harness? How is your harness going to perform and function in the environment of its intended use? We'll talk a little bit more about some of these in just a moment. Again, on the qualitative side, how ergonomic is the harness? How does it fit you? How does it feel? This is important if you're going to be hanging in a harness, for instance, in rope access work, things like that. So how comfy it is versus ease of movement. And then secure fit is really important for all harnesses because all harnesses don't fit all people the same. And there is a temptation to order one harness to fit everyone in a workforce, and that may work with some harnesses, but some harnesses, they just will not fit different frame sizes properly. So pay attention to how the fit is going to fit your personnel. Ease of donning and doffing is important to many people, and then the weight, depending on what you're doing, how long you're going to have your harness on, and what it needs to perform. The weight could be an important consideration for you. We talked about adequate tie-in points on a harness. Well, pictured here is a harness that has virtually every tie-in that you could want. All harnesses certainly won't have all of these tie-in points. In fact, most of them won't have all of these tie-in points. If you're in a fall arrest situation, you will need to have the dorsal attachment that you see on the upper left, and if you're in a confined space environment, you would want the shoulder attachments, such as in the right. Other than that, the standard attachments would be the sternal attachment in the front, and the waist attachment, and then the dorsal attachment for fall arrest. These are full strength rated tie-in points. Now, the positioning rings that you see at the waist in the picture on the right are not intended for fall arrest, but they're intended to be used as a pair with a positioning lanyard for work positioning. Let's briefly go over some categories of NFPA rated harnesses just to show the differences that you might need to consider. Any harness on a fire ground generally will have to be an NFPA Class 3. It will have a full body design. It'll have protection from inversion and also significant impact. A Class 2 harness, NFPA, is a basic seat harness, and you may find this appropriate for many rescue applications. It can be appropriate for non-fire ground use. And even in mountain rescue, although you'll generally see alpine type harnesses in that environment. But this is, the intent here is just to point out that your choice in a harness needs to be targeted to what your need is. Again, there's another category for NFPA as a limited application, which is just an escape harness, which is intended for a temporary specific use. Climbing harnesses we referred to before are really governed by UIAA, and they're just a front waist attachment point. This is okay for mountain rescue applications, but that's about it on the rescue side. We wouldn't recommend this for any industrial or fireground or heavier rescue applications. Another type of harness is a caving harness, and this is a harness that sits really low on the waist and is optimized for ascending, really better used in conjunction with an appropriate chest harness. So now when you're looking at harnesses, besides your environment, you need to consider how it's going to be used. The ANSI Z359.1 covers both, for instance, fall arrest and fall protection. So depending on how your harness is going to be used, you need to look at what requirements it has to meet and what it's tested for. The fall protection is a key one, because for over 10 years now, a full body harness with a dorsal attachment was mandated for fall arrest situations. And now there are new documents from ANSI that permit a frontal attachment for some limited fall arrest. You have to limit the distance of potential fall. But for instance, if you're going to be in a fall arrest environment, you'll need to have a harness that has the appropriate attachment points there, and then it's a full body harness. One other thing to consider here is, are you going to be using a harness in a situation where you may have to perform rescue after a fall? So really the other considerations to look at with harnesses, most important, fit is key, because the different styles will fit different people. You have to properly adjust them. Unlike the picture on the right with the loose leg loops, that could be very, very painful if you went up to height with loose leg loops and fell on it. But you want to be able to adjust the harness so that it's a secure fit. And again, look at your potential use. Are you going to be in an environment where there may be a potential fall? That's not always the case. For instance, you could have a situation where your harness is used to prevent you from reaching the edge, so you never would be in a position to fall. In that case, you may not have to have a harness that would be able to arrest your fall. Again, look at prolonged suspension possibilities, because if you're going to be hanging in a harness all day, such as in rope access work, you need to have a harness that has appropriate adjustments and fits you appropriately so that you can stay in a prolonged suspended state comfortably or relatively comfortably. And again, look at the need for self-rescue. So for harnesses, no one harness is best suited for all situations. Did want to point out one thing. If you are in an environment where you may take a fall, you would really like to have a harness that had an attachment point near your center of gravity, because the incidence of whiplash is much, much higher as that attachment point moves away from your center of gravity. So the forces in a fall are going to vary according to the harness, how it's worn, and where you attach. But in a falling situation, the harness has a lot to do with the mechanism of injury, and you need to be considering that. Also, if you're in a rescue of a person who has fallen in a harness, you need to think about what their mechanism of injury might be. Care and maintenance for harnesses is similar to other soft goods. Obviously, periodic inspection and inspection before each use. Stitching, look for nicks. Keep it clean. Wash it with non-detergent soap, and then retire it when it's damaged or worn, or if you're going past the manufacturer's recommendations. And one thing to pay attention to is the shelf life. From DuPont, the shelf life of nylon and most other fibers shouldn't exceed 10 years. So you should look at retiring a harness regardless of its use after it's reached 10 years shelf life. So now we'll move to webbing. This is an interesting area. We all tend to use webbing. The mill spec that you see listed there is no longer in force, but it's the standard that people remember. So the mill W5625, you'll see some webbing manufacturers say that they have mill spec webbing. Well, what they're really saying is they're meeting the specifications that were in that standard. It's now been moved to the Parachute Institute, who are maintaining that standard. It still has the same number, but many people won't recognize PIA W5625. But just what you want to do, there's so many sources of webbing out there, you just want to be sure that you order quality webbing and that the manufacturer has tested it to that type of standard. So webbing that's 1-inch tubular webbing would be 4,000 minimum breaking strength of 4,000 pounds end to end, or 7,000 tight in a loop. 1-inch solid webbing, 6,000 and 8,500 pounds respectively. So just be sure to buy your webbing for life safety purposes from a reputable source. Now we talked about the two types of webbing being flat and tubular. That's usually nylon. 1 and 2 inch is the most common. There's also spectra webbing. I just wanted to point out here that it's a high modulus fiber. It's usually 9/16, and it's also almost always sewn. Well, the reason that it's sewn is that it's a slippery fiber. It doesn't hold a knot very well, and these are very, very static. So you would never want to use them in a way that you would fall on them. Now, sewn products made from webbing, there are standards that you want to look at from NFPA or ANSI Z359, because now you're moving away from the material and into more of a component. So you want to look at the strength of the product, the finished product that's made from the webbing as it's tested. You're less concerned now with the strength of the individual parts, but more how that finished product performs. As we move to helmets, again, there's a variety of helmets out there to choose from, but you definitely want to get a helmet that meets an applicable standard. ANSI Z89, NFPA rated helmets are for urban search and rescue and structural and wildland, and ANSI Z89 will cover almost all of your industrial or work and rescue situations. UIAA is appropriate for climbing helmets, and that's generally the extent of what you'd see for UIAA. But the important point here is if your helmet use is, if you're ever going to use your helmet in a high angle environment, you need to look for these types of features. And it needs to have full coverage. It needs to have good visibility. 3-point retention, very important, because the 3-point retention system will keep your helmet on your head even during a fall. Examples here on the left are the 2-point retention systems. Those are not something you want to use if you're ever going to use your helmet in a high angle environment. On the right, you'll see the 3-point attachment. It'll keep the helmet on your head even during a fall. Water rescue helmets are kind of a specialized helmet. They have full coverage, but they have a low volume. You'll want them not to be able to have a lot of open space inside. If appropriate, drain holes in the top. It could be, you could get yourself in a dangerous situation if you choose to use a helmet, for instance, in a swift water environment that is not a water rescue helmet. The helmet could basically act as a parachute effect and pull you under. So again, pay attention to your environment, your application. get the appropriate gear. Let's move on to some hardware. Carabiners particularly here. The carabiners we're going to talk about here for life safety applications and rescue applications will be governed by standards like NFPA 1983, ANSI Z359, and ASTM. Now, carabiners that we're talking about are going to be in the 5,000 to 13,000 pound strengths. That varies depending on your gate being closed, open, or cross-loaded. So just pay attention that the 5,000 to 13,000 pound is only for full strength used in the strongest configuration of the carabiner. And we'll see in a moment how those variables will greatly influence the strength of the carabiner, and you need to consider them in selecting your equipment. Briefly, a review of the parts of the carabiner. When we talk about a long axis, we're talking about the length along the spine of the carabiner. The short axis is the axis that goes across from the spine to the gate. The gate hinges at one end. That's the hinge. The other end is the nose. When we talked about gate open, the picture on the left demonstrates how this is tested. So in this case, the gate is fully open. Well, what we're going to see is that the strength is only about 25 to 30% of what it would be with the gate closed. So you've now lost, with an open gate, 70 to 75% of the strength of your carabiner. Well, this is something to consider. The picture on the right shows a non-locking carabiner in a climbing situation. And the reason that this is important, there's something called gate flutter that they found that sometimes the vibration from the rope moving can cause the gate to move and basically chatter or flutter. Well, if you took a shock load at the time that it happened to be open during a flutter cycle, you've compromised the strength of that carabiner by 70 to 75%. So in selecting your gear, and if you're ever in a situation where you think you might have an environment to cause gate flutter, you might want to use a locking carabiner and not choose one that doesn't lock. This is an example of testing the minor axis loading on a carabiner. Three-way and across the minor axis. This shows the same kind of strength as a gate open. Now this is really important because of paying attention to cross-loading your carabiners in your system. You need to realize that, for one, if you do it accidentally, it will cause you a 70 to 75% strength loss in the carabiner, but also to realize that in your selection of equipment, you may have to think about how you're going to implement your system. For instance, on the right, this is just not rigged very well, but you could have prevented this perhaps with a longer strap or a longer anchor strap or a rigging strap, a larger carabiner, things like that. So if you're going to get in a situation where you're going to have to implement a system using carabiners that you're going to tie into other components like this, think up front about what those situations might be and order appropriate sizes of equipment and strengths of equipment. So here's a situation that we see relatively commonly. It's where it's not quite a cross-loading of the carabiner, but it's much less than ideal. And this type of loading, when tested, shows we lose about 30%. So it's still a significant strength loss, but again, this situation could be prevented perhaps by a longer anchor strap or rigging strap or a larger carabiner. Here's the actual test for those situations that we were just showing. And you can see, for instance, the minor axis with three-way loading. Actually, let's look at the gate open at the very bottom. The gate open is about 2,500 pounds braking as compared to used in a proper configuration with the gate closed is 10,000 pounds at the top. Well, one way to help mitigate this when you're choosing your gear is perhaps to use rigging plates that can help you avoid loading a carabiner improperly by trying to hook too many things into one carabiner. So this is a quick way to avoid that. Okay, it adds a little bit of weight, it's not much, and extra carabiners, but these rigging plates are typically exceed 10,000 pounds in strength. Another component you'll want to carefully select are your pulleys, because there are so many types of pulleys out there. Many have specialty uses. You need to consider, do you want your pulleys to be prusik minding pulleys? Do you want them to mind prusik knots on your line without having to have a person devoted to prusik minding? Do you need a double sheave? Are you going to have to pass knots through it, which would require a pulley, say like the Kootenai, the gold pulley there you see on the right? So you just need to consider how you're going to implement your pulleys. Also, you want to look at how your pulley is rated strength-wise. Here's a comparison of NFPA ratings. NFPA rates things often in G for general use or light, or L for light use. And in this case, you'll see that a G-rated pulley is over 8,000 pounds, and an L-rated pulley is just under 5,000. Swivels are another way that you could mitigate some of the issues with inappropriate rigging, because it could allow a rotation into a better rigging angle, and it also helps prevent twisting of ropes. There's no NFPA specific test for swivels, but there is a strength pull test. Descenders, interesting devices. We'll want to pay close attention to your choice in descenders. Again, we have NFPA 1983, and it talks about 3 different types of descenders: general use, light use, and escape. The important thing here with descenders, though, for NFPA is that the standard is only an end-to-end pull test, so it really is not very useful for helping you select an appropriate descender, only from the standpoint of end-to-end pull strength. But descenders are almost always used on a rope as a rope grab, so you don't, the situation that you're going to use them in is not one of end-to-end pull on the descender. You're more interested in how the interaction between that rope grab and the rope are going to compromise your system or weaken your system, or at what point they're going to fail. To this end, ISO 22159 is much more informative. So just keep that in mind, that if you buy a descender has an NFPA rating, that isn't going to tell you a whole lot about how you're going to how it's going to perform in your system. Some of the considerations you really need to look at are the friction that you're going to need from your descender, and if you're able to vary that friction if you need to, such as in a brake rack, they can be more bars can be switched in or taken out even while under load to vary your friction. Are you going to need to pass knots, such as the brake tube you see in the lower center of the pictures there, can pass knots if you need to do that. What is the frame strength? Well, that's the one place that the NFPA ratings for descender comes into play. Do you need a panic stop? In other words, if your descender is used in a condition where you're worried that a person in panic could pull the handle on the descender to its full length, or squeeze, whichever its configuration is it made to stop in that situation? Also, does it provide a hands-free lock-off, or will you have to use an extra lock-off on the rope? And what is the impact absorption on your descender? I'm not going to brief this chart on the ISO 22159, but I just wanted to include it to show the different types of aspects of these braking devices that ISO considers, and it just shows you that it goes into a little more detail of looking at how you'll actually use them. Another type of descender is a personal escape descender, and these are rated NFPA-E. They're really made for smaller diameter ropes for bailout kits and such. They have to hold 13.5 kilonewtons without failure, but that sometimes limits the use of smaller ropes in many of these devices. Ascenders are rope grabs. Well, ascenders are governed by these three standards: NFPA 1983, ANSI Z359.1, and UIAA. The vast majority of ascenders out there are under UIAA, but these are really made for personal use and less appropriate for heavy-duty use, such as in rescue applications. So these ascenders are used for halt systems, or used for positioning or ascending ropes. And you have to note that not all of these will work well in all of these environments. The most important thing to bring up here is never use them in a situation where they could be subjected to a shock load or a dynamic load. The two ratings that you see there in orange on the screen are the NFPA-L and NFPA-G, which says that it has to go up to that amount of force without damaging the rope or slipping on the rope. But note that the UIA rated devices, which is the big majority of ones you'll find out there, are significantly less than that. And so you have to be really careful. Ascenders tend to have sharp teeth, and you have to be very careful that you choose to use this in a way that you're not subjecting it to a sharp load or over stressing this device, because it will damage and fail your rope if it's overstressed. The care and maintenance of these devices, again, are as other hardware, is store in a clean, dry location. You can wipe them down and clean them as necessary. If you lube them, do only so according to the manufacturer's instructions, and never retrofit or modify or do your own repair of life safety equipment. I'd like to touch on litters. We don't really have, I'll just make this statement, we don't really have a good standard, current standard for litters. There is a mil-spec standard that's about the only one to use out there, but the testing method for that is basically to load the litter full of shot, heavy weight, which kind of evens out the load across the litter, and is not very representative of a real-life environment. There are standards that are being written. They're in the process for NFPA and ASTM. So when selecting a litter, the mil-spec standard is probably less useful to you. You really want to pay attention to who your manufacturer is of your litter and how they test, because you may have to often depend on the manufacturer's testing to get useful data. Some of the types of litters you might choose, a basket style litter, many people call it a Stokes litter, but it's really the generic term is a basket style litter, and some of these exceed 2,400 pound strength, but again, you'll have to pay close attention to how the litter that you're considering has been tested by the manufacturer. Plastic litters are popular because they're less expensive and they're lighter, but be very careful of using a plastic litter because they're usually much weaker than the other styles of litters. So look at your application and see what you might be subjecting your litter to. This would not be appropriate, for example, for a vertical evacuation. And the manufacturer's maximum load rating for this litter is about 600 pounds. A composite shell litter kind of combines the advantages. Another advantage of a plastic litter that people like is that the plastic litter, they believe, provides a little extra protection for the patient in that it can be slid. It kind of covers their entire back, and so it provides a little protection there. Well, the composite shell will do the same thing. So this is an appropriate litter for most situations, and it has both the additional protection plus the stronger frame. Let me see if I can get this off. There we go. The SCED is another special use type litter. This might be appropriate if you have a limited space in which to work. It's also can be used where time is of the essence, and you need a quick in and out scenario where the time factor is more critical than patient stabilization, because you won't be able to stabilize quite as well as in a full litter, one of the other rigid litters that we were looking at before. But this is very appropriate for many situations, and one thing to point out here is that you need to be sure and not improperly rig a litter like this, because in this litter each grommet hole singly is about 400 pounds forced to fail. So you need to rig it according to the manufacturer's instructions, which will include using multiple holes. There are many other specialized litters or litter-like devices, but again, you're going to have to look at your situation and your need, and then carefully examine the manufacturing's testing and their intended purpose for these litters before deciding if they're appropriate for your use. Well, that's kind of a top-level summary of selection, care, and maintenance. Hopefully it is prompting you to ask the right questions, to consider your important factors for your application, and also stressing the importance to research the key specifications that apply to the equipment that you're choosing and the environment in which you're going to use it. So that's SCAM. And you will hear that term again. Selection, care, and maintenance is coming soon to NFPA documentation near you. I thank you all for your time and attention today, and hopefully this has been somewhat informative for selection, care, and maintenance.